Welcome back to the Deep Dive. Today we're focusing all our attention on, well, one of the quietest miracles in your kitchen, the fig.
It looks so unassuming, doesn't it? I mean, soft, dense, sort of pear-shaped. But when you handle it, you immediately notice that heavy, almost yielding quality.
Right. And then you bite into it.
Yeah.
And that's the moment of maximum surprise for me. You expect a core, maybe a single central seed like an old plum or a peach. Instead, you find this cavern just packed tightly with what feels like hundreds of tiny, crunchy jewels.
Those are the seeds, right?
Well, those tiny, crunchy bits are key, but they are not the main story. We are launching a deep dive into the fig because contained within that dense, sweet package is one of the most remarkable and ancient secrets in the entire botanical kingdom.
Oh.
Our mission today is to reveal why the fig is technically not a fruit at all, and what astonishing creature it had to partner with millions of years ago just to exist. And that, for you, is really the shortcut to understanding this incredible biological pact.
Yeah.
So let's start with history, because the fig is it's ridiculously old.
It really is. It's not just a foodstuff. It's a foundational pillar of human civilization.
Wow.
Exactly. When we talk about ancient cultivated foods, we always mention wheat and barley, right? The staples that allowed civilization to rise.
Of course.
But the fig, Ficus carica, it's in the archaeological record even earlier than those essential grains. It is truly one of the oldest known domesticated plants.
That's astonishing context. So we're talking about something that predates organized agriculture as we even understand it.
Yes. Its origins are firmly rooted in the Mediterranean and Western Asia.
So why did it become so foundational so quickly?
It offered this complete package of nutrition and convenience, especially when dried. For the ancient Romans, the source material notes that dried figs were absolutely crucial.
Not just a dessert.
Not at all. They were non-perishable, energy-dense calorie bombs.
If you think about the logistics of supplying a traveling Roman army, you need food that is light, durable, and packed with fuel.
Right.
A pouch of dried figs perfectly fit the bill. It let them sustain these huge campaigns so far from their supply lines. It was military logistics in a single chewy package.
In a single chewy package. And this utilitarian use was matched by its deep symbolic significance. Across multiple ancient cultures, the fig represented abundance, peace, and particularly fertility.
I mean, we all know the famous image from the Bible, right? Where fig leaves are the first form of clothing.
That's right. But the tree itself is referenced hundreds of times as a symbol of prosperity and homeland. Think of that peaceful life symbolized by sitting under his own vine in his own fig tree.
It's a metaphor for true security.
And domestic tranquility, exactly. Then there's the Buddhist connection you mentioned earlier, the Bodhi tree.
Yeah, what is that?
The Bodhi tree, where Siddhartha Gautama, the Buddha, attained enlightenment, is a type of fig, specifically the Ficus religiosa. Yeah, so this gives it incredible depth. It's a species of fig associated not just with physical nourishment, but with spiritual wisdom. It really solidifies the fig's ancient role.
A keeper of history and knowledge.
Spanning vast distances and belief systems.
That is amazing context. And it transitions so beautifully to its identity on the plate. Because it has this incredible dual culinary life.
It really does. You see that stark contrast in flavor and texture. When it's fresh, it's this delicate summer treat. It has that honeyed, sometimes slightly jammy sweetness.
But the structure, it allows that sweetness to be brilliantly balanced by savory elements.
That's where you get those famous pairings.
Right. Sliced fresh fig with sharp, salty goat cheese or wrapped in salty prosciutto. The fig acts as a counterpoint, elevating everything else.
Then you have the dried version, and it transforms entirely. As the moisture leaves, the sugars become intensely concentrated. It turns into this durable, chewy, almost caramel-like energy source.
That long-lasting winter staple that kept those Roman armies marching.
That's the one.
It is efficient energy packaging. But now we have to turn to the core secret, the botanical truth that underpins everything we just discussed. When you bite into a fig, you said you are not eating a true fruit. Let's unpack that. What exactly are we eating?
What's fascinating here is that you are consuming an inverted flower cluster. It defies the standard definition of a fruit, which typically develops from the ovary of a single external flower.
Okay.
The fig, instead, decided to fold itself inward.
Wait, an inverted flower cluster. So that entire fleshy sweet envelope we hold in our hand, is that essentially the stem tissue that is swelled up?
Precisely. Botanically, we call that unique structure a syconium. The syconium is the fleshy vessel that holds hundreds of individual flowers inside.
So instead of blooming facing the sun like an apple blossom.
All the fig's tiny flowers are tucked inside that protective, fleshy container. They're completely hidden from the outside world.
That's a huge difference. In a standard fruit, the seeds are protected by the fleshy ovary wall. But here, the flesh is the protective wall for the flowers themselves.
And those hundreds of crunchy little bits inside, which everyone thinks are the seeds,
Yeah.
those are actually the true fruits. Each one of those crunchy particles is called an achene, and each achene developed from one of those minute internal flowers.
So when we eat a fig, we're actually eating hundreds of tiny true fruits, all housed within this inverted flower structure that we just perceive as the main fruit.
You got it.
That makes the texture, that simultaneous sweetness and crunch, it makes so much more sense now.
It does, but this structure, while brilliant for protection, it creates a monumental problem for survival.
Okay.
It raises the most critical question in the fig's entire existence. If those flowers are sealed inside the syconium, how in the world are they pollinated?
The wind can't get in.
Bees are too large to access the inner cavity.
This sounds like a biological impossibility.
It would be, without a highly specialized, singular intervention. This is the ultimate life or death contract. The fig is entirely dependent on one specific insect for reproduction.
And only one.
And only one. The tiny fig wasp.
Wow. The sheer specialization of this relationship. It must be the result of millions of years of coevolution.
It is. They exist solely because of one another.
So how does it work?
So the fig has this tiny little opening at its base, which is the only entrance and exit to the syconium. It's called the ostiole.
The ostiole. Yeah.
A pregnant female fig wasp, covered in pollen from the fig she was just born in, has to squeeze herself through that incredibly tight ostiole opening.
I imagine that passage is destructive. It sounds like a forced entry.
It often is. It shreds her wings, breaks her antenna, and this is where the sacrifice comes in. Because the passage is so narrow and jagged, once she is inside the syconium,
She can't get back out.
she cannot turn around or exit. She is trapped. Her one and only mission is to lay her eggs inside the fig's tiny flowers, converting them into nurseries for her young.
So she sacrifices her life for the next generation.
Absolutely. She dies inside the fig shortly after laying her eggs. But crucially, while she is depositing her eggs, she also deposits the pollen she carried on her body.
Pollinating the female flowers inside.
And there you go. The fig receives the pollen it needs to mature, but the cost to the mother wasp is her life.
That is just astonishing. So she dies, the flowers are pollinated, and now the next generation of wasps is developing inside. What happens next?
The eggs hatch, and the male wasps, they mature first. Their role is pivotal, but really short-lived.
Okay.
They mate with the still developing females inside the fig. Then, because they can't exit the ostiole, they collectively chew a critical escape tunnel right through the wall of the fig itself.
They are literal engineers of their own escape.
Paving the way for the future, exactly. This tunnel is only for the newly fertilized females.
Right.
These females emerge, they collect pollen on their way out through the tunnel the males created, and then they fly off, desperately searching for a new receptive fig.
To continue this exact astonishing cycle,
Yeah.
it's pure, specialized, and brutal mutual dependency.
Yeah.
Okay, we have to address the inevitable question. The question that I know every listener is asking right now, because I'm asking it. If a female wasp dies inside the fig, am I eating a dead insect when I eat a fig?
That is the core concern, isn't it? And the answer is reassuring. Thanks to nature's incredibly efficient cleanup crew, the fig produces a very powerful proteolytic enzyme called fission.
Fission, like a natural meat tenderizer, but for the wasp.
Precisely. Fission is a powerhouse. Its main biological function is to completely break down and dissolve the entire wasp's body, wings, antenna, everything.
So it digests the remains.
It does. It transforms the insect protein into amino acids and nitrogen that the fig actually reabsorbs as it matures.
Wow. So by the time that fig is ripe and sweet and ready for harvest,
there is absolutely no crunchy wasp left inside.
the fig has just recycled the resource. It turned a tragedy into nutrition.
That's exactly right. And this leads us to the modern context, because while that biological story is fascinating, most commercial figs you buy in the grocery store are actually spared this entire drama.
Right. We regularly see varieties like the brown turkey or the black mission figs on the shelf. If they're sealed up like that, how are they produced on a mass commercial scale without needing these tiny wasp partners?
They're produced without the pact because these specific cultivars are parthenocarpic.
Parthenocarpic. Okay, what does that mean?
It's a key technical distinction. It just means they have been selectively bred over time to develop the syconium, the fruit, without needing the wasp for fertilization. They ripen and sweeten automatically.
bypassing the entire life or death contract.
The whole thing. So the fig's ancient biological mystery still exists in wild figs, but modern agricultural engineering lets us enjoy the sweetness without the intense drama.
Which makes these common varieties a non-controversial, viable choice for mass production.
It's a biological safety net. But even with the parthenocarpic varieties, you are still eating a syconium. You're still eating an inverted flower cluster. The fundamental botanical truth remains the same.
So what does this all mean? We've taken this unassuming package, the figgin, and revealed that it harbors a story of ancient history, intense flavor, and this deep, complex biological contract. It's a miracle of coevolution.
If we connect this back to the bigger picture, the fig really stands as this beautiful symbol of just how complex mutual dependency can be. It required sacrifice, specific engineering, and chemical recycling to create something this universally nourishing and sweet.
Absolutely. We started this deep dive with the premise that the fig is technically an inverted cluster of flowers reliant on a specialized wasp. Now that you know the fig can literally dissolve the organism that allowed it to exist, and that every tiny crunchy bit is a separate true fruit, does that knowledge change the way you interact with it?
It certainly transforms a casual snack into an appreciation for biological ingenuity.
Agreed. So what should you mull over until our next deep dive? If the most common figs are engineered to avoid the wasp pact, which fig should you seek out next? A modern variety with creamy goat cheese, or a wild variety accepting the ancient terms of the contract for a taste of true evolutionary history? The next time you see a fig, you know you're holding a profound secret.